Hello students, welcome to SAM class. Today we are doing the chapter Magnetism and Matter and EMI combined. So now first let's understand what is there in the portion and what is deleted. So in the deleted portion we have the magnetic field intensity due to a magnetic dipole on the axis or perpendicular to its axis. Torque is not there. Para-diaferromagnetic substances and examples. Electromagnets and factors affecting their strengths and permanent magnets. So these are not there. So let's see what kind of question we can expect in 2021. Okay, and what are the previous year's questions and how they have asked. Let's see. So the chapter is very simple, not much. Again, same thing. You just need to go through with the examples very thoroughly. Okay, and you'll be able to solve all the questions. You'll be able to solve all the questions. Not much is there, just the basic formulas you should know. So let's start it. The first question, if a bar magnet is cut into two equal pieces along its length. So let me make it clear how you can solve this question. And along with this, I'll take one more question in this. Let's say we have a magnet. So magnet is the North Pole, South Pole. Okay. Now, and it is of length L. So what is the magnetic moment of this? So magnetic moment is nothing but M into what? L here, correct? Now, let's say you're cutting it. Now, let's say you're cutting it into two parts. Now, you can cut it in two ways, either like this or like this, correct? One is, one cutting is perpendicular to length, okay? So in perpendicular to length, you make it like this, two small magnets. So here the pole, it becomes like North Pole, South Pole, again two poles. We know magnetic monopole doesn't exist. So whenever you cut, it will again form a North Pole, South Pole, North Pole, South Pole. Or you can cut along its length, along its length. So when you cut along its length, you'll get something like this. One magnet half like north and south, and again here half north and south. So these are the two ways of cutting it. Okay. Now when you're cutting in the first way, okay, perpendicular to its length, then what happens? Magnetic moment here length divides. L becomes L by 2 and this becomes L by 2. Correct. So the magnetic moment becomes M into L by 2. Correct for each. So what happens? The magnetic moment is what here? M by 2 only. Correct. Now in the second case, what happens? Length is same. Length is of L only. But the pole strength changes. Here the pole strength, north and south pole strength becomes M by 2. So the magnetic moment is equal to what? Again here M by 2. So what you can see, the question what they have asked is, if a bar magnet is cut into two equal pieces along its length with this condition, in that case what happens? Both pole strength and magnetic moment becomes half. See, pole strength is also half, magnetic moment also becomes half. So very simple. Next time they can ask simply about this also. Okay, when you're cutting perpendicular to the length, then what happens? So very simple question. You need to just break it down and you need to solve it. Let's see the next part. Two identical thin bar magnets. Okay, so very simple. You need to understand. So let's say we have one bar magnet like this. Okay, and then another bar magnet. We can make it like this. Okay, now let's say this one is N1 and this one is S1. This is N2, S2. Okay, so this is of L length and this is of L length. Correct. So they're asking is what about this? Okay. So here the pole strength, let's say we have taken M and M for both of them. One very simple formula. Okay. Understand. It's just like two vectors here. One, it has M1 here. Another, it has M2 here. And you're asking what is the resultant, sir? So resultant M, or let's say M dash can be given as what? Root under of M1 square plus root under of M2 square. Correct. And that is equal to ML whole square. Magnetic moment is what? This only. Pole strength into the length. Correct. So what do you got? Root 2 ml. That's it. Correct. So that's simple. Nothing was there in this question. Okay. We could have done a lot of places. We'll see. We could have done taken this length as L, this length as L, this length we would have got root 2 L, and then pole strength is M multiplied. So the moment you multiply, you'll get the same answer. So again, it is the same thing. So very simple question. Okay. Now this part is from diapara, so deleted. No need to do it. Okay. Next, this part is very simple, directly formula. If you remember, not showing the derivation, it is what? Inversely proportional to what? Temperature, no? Directly. So that's it. Clear. If you know the formula, you'll be able to do it directly. Derivation I haven't shown. Okay. Now, again, this is from deleted portion. Now this part also again deleted portion, so we can expect more questions from the Earth magnetism this side. Okay. Basically for the, but yeah, Messner's effect we can go through. It's a good concept. Okay. If I'll be teaching for the whole thing, I'll explain it in details. Okay. So now see this question. Now this question, what is it telling? That a jet plane is traveling, okay, at 450 meter per second. Horizontal component of the Earth's magnetic field is given, and angle of dip is given. Vertical, they have told. See, directly you should remember tan of what? Tan of delta angle of dip is equal to what? Vertical component by horizontal component. That's it. If you remember this formula, done. That's it. What else? We don't need anything. They've already given me the horizontal. So tan of vertical is equal to what? Earth's horizontal into tan of 30 degree. Correct. So that is equal to 4 into 10 power minus 4 into 1 by root 3. Now here a lot of people, they'll start solving. Sir, 4 then divided by this, all that. Why? See, 4 by root 3 definitely can't be 4. So first option wrong. 4 by root 3 has to be less than 4. So again wrong. 4 by root 3 can't be exact equal to 3. Correct, wrong. So it has to be this value. So not always you need to start solving it, because see, rest the powers were all same. So you can do it like this also. You need to understand how to attempt the paper, and you can solve it in a much faster way. Like 30 seconds it will take, not more than that. Everything, see, all this you can do it in your brain only, no? This part also you can do it in your brain. So directly writing this part, okay, so 4 by root 3. So 4 by root 3 directly you can do it, okay? So what we have seen from this part is the questions are not much repeating from this chapter, and even the concepts. So whatever the concepts they've already asked, they'll try to ask something from a different one. So what you need to do is the ones which are left, which are not covered in these questions, try to solve more of them. Okay. So about magnetic field lines, magnetism and Gauss law. Okay, that part is important. Okay. How to implement the Gauss law in the what do you say bar magnet. Okay. And Earth's magnetism, important. Magnetization and intensity, the part which is not covered, they have not given much questions from that part, go through. So we'll be able to, what do you say, get a question which will be more, what do you say, which has a more chance of coming to for the 2021. So according to the data what we have seen, the questions are not repeating from this part. Okay, so try to do the questions which are not in this. Understand what we have done, okay, the PYQ, but try to focus more, revise more on the questions which haven't been there, and the concepts or the formulas of 12th which have not been asked as of now. They're giving you a direct simple question, but they're not repeating it. Okay, so we can understand this part is important. Okay, concepts similar to this. Okay, and concepts where they haven't asked much about what you say Earth's magnetism's other part, other formulas. Okay, now after this, let's start the next chapter, that we have electromagnetic induction. Now, in electromagnetic induction, nothing part is deleted. So let's see how will we solve these questions. Okay, the first question that we have here is a very important question. Now you need to understand this question is, when a metallic plate swings between the poles of the magnet. So let's draw a metallic plate. So let's say we have a magnet here. Okay, my diagram is bad. Okay, so forget about that. And let's say we have a north pole here, and field lines are going correct. Now what you have done here, now what you have done here is you have made a what? metallic plate which is swinging. Correct. Inside is like this, let's say. Okay. Now it is swinging, so magnetic field lines are passing through this. So what happened in this? Okay. So this experiment, if you want to remember, you could have given you directly the answer. But understand, this whole setup, our Foucault sir, in the year 1895, he observed that whenever a metal moves in a magnetic field, okay, or whenever you change the magnetic field through a stationary mass of metal, okay, what happens? Induced current is getting. We are getting induced current, induced EMF, and then induced current. That's it. Okay. So whenever the magnetic flux or the magnetic field lines is changing, what we are getting? Induced current. Now this induced current it flows, okay, in the metal in form of closed loops, forming eddy current. See, a lot of people they don't remember this and they'll do wrong. So this, what do you say, induced current. So first, what happens? See, step by step, understand. Very simple. So what do we have? Changing magnetic flux, changing magnetic flux. Now this changing magnetic flux gives me induced EMF. This gives me current. Okay. And now this induced current, it comes in the metal in the form of closed loops, and that is known as eddies or whirlpools. Clear? Okay. And hence we get the name of the current as eddy current. Now the direction of the eddy current is given by Lenz's law. Direction we get it by Lenz's law. Okay. And what does this says? Lenz's law always says that whatever happened opposes the change. The current comes in such a way, it acts in a direction so that it opposes the motion of the conductor. Done. See which option. See, eddy currents are set up inside the plate and the direction of the current opposes the motion of the plate. So we need to understand, very simple. Changing magnetic flux, if the number of field lines is changing, what it does, it induces an EMF. Induced EMF produces a current. Current comes in the what is the metal in form of closed loops that forms eddies, okay, or whirlpool, okay, and that's why it is known as eddy current. Now the direction of the eddy current is such that it opposes the motion of the plate. Okay, clear? Newton's law we know, no, law of inertia, correct? What it does, always opposes the change. So here also we try to restrict our body also. The moment we say tomorrow we'll study a lot, so what happens? It opposes to change. Okay, why tomorrow? Let's start with day after, or day after. Today we'll rest a bit more for, okay, and then we'll start. So always it opposes the change. And if you're studying a lot, again, if you don't study the next day, or like let's say you're an athlete and every day you're going for running 2 hours, suddenly you stop. That day your body will be like, your body will behave differently, like something you're missing because your daily routine has changed. So make a habit of daily studying, okay, or daily getting the knowledge input. So you'll do a lot of wonders. Okay, if you're a daily, what do you say, studying person, you will do way good than just studying at the last point. Still, since you have very less time left, so your brain will try to resist. Don't study more. Okay, you don't have a habit, your head will start paining and all that. Try to overcome that. Don't be a slave of your brain, be the master of it. Okay, let's see the next part. In a given step up transformer, so first thing is, a lot of students they don't understand what is step up transformer. So step up transformer means, what does it means? We get a what? More higher voltage, correct? The output voltage is high. Now they're talking about the current. So see here, what we do, very important. We know output voltage is high. Output. So you should know this one. Okay. Output voltage is high. So in order to get output voltage high, what we need to do? In order to get output voltage high, what we need to do? Anybody? Do write it in the comment section. What about the number of coils in the secondary and primary? Will it be more? Will it be less for a step up transformer? Okay. Now we know that, we know according to Ohm's law, so output voltage is high, correct? So what about current? Wait. So what about current? So voltage is high. So you'll say, sir, Ohm's law, sir. We remember voltage is directly proportional to current. So voltage high, current high. Correct. So voltage high, current high, but in this case, what we do, it is not. Why? Here in this case, while transferring, okay, while transferring, we keep in mind that power should remain same. Power is constant. Power is constant. So power is equal to what, students? VI. Power is equal to what? VI. Voltage into current. So if I'm increasing the voltage, my current has to decrease. If I'm increasing the voltage, my current has to decrease. So here we tried the power remains same while sending and receiving. Okay, in the transformer case. So that's why if voltage is high, the current has to be less. And if the current is less, what about the magnetic field? So current and magnetic field is less in the secondary winding. So see, they can ask about current, which is less in secondary. Okay. And same thing about magnetic field. This is also less in secondary. So if it is less in secondary, so what does it mean? Greater in primary, correct? Now, same opposite happens in what? Step down. In step down, what will happen? Then voltage will be low on the secondary. So voltage low means current and magnetic field will be high. So you should know. See, this time they have given about step up. Next time they can give about what? Step down. So that's why I put up this also. Like while doing this question, you can revise this. In step down, what will happen? Out voltage is low. So sir, current is more. Again, current is more than magnetic field is also more. Okay, clear everyone? So see, we have covered a lot of concepts in just one question. Okay, so we learned about what is a step-up transformer. A step-up transformer where we need high output, where we need high output voltage. In order to bring high output voltage, what we need to do? The number of windings I left on you. It should be the number of windings, where it should be more or less. You should put it in the comment section so that I can know, like, a lot of students, they're following, they're going through the chapter also. And if voltage is high, it doesn't mean that current has to be high, because we're keeping the power constant while sending and receiving. We're keeping the power constant, very, very important, while sending and receiving. So that's why if voltage is power is constant, so if voltage is high, current has to be down, current has to be less. That's it. Okay, coming to the next question. See, SI unit of magnetic induction, anybody can say Tesla. We know Tesla cars are coming, correct? So one Tesla and Tesla factory has been opened in Bangalore also. So one Tesla is equal to 1 Weber per meter square. I think so you all know that. Okay. Next, quantity that remains unchanged in transformer. See, in transformer, we know one quantity that remains unchanged is frequency. So always input frequency is equal to output frequency. Okay, keep that in mind. So we increase or decrease voltage, and by increasing or decreasing voltage, the current will also increase or decrease. Correct. But what remains same? The frequency remains unchanged. The frequency remains unchanged. The transformers work on the basic principle of electromagnetic induction and mutual induction. The voltage between two devices can increase or decrease, but the frequency remains same. Always the frequency remains same. Okay. Next. So we have a magnetic flux in a coil, and they're asking what is the magnitude of induced EMF. So see, magnetic flux, what is the formula of induced EMF? E is equal to what? N into d phi by dt. N into minus N into d phi by dt. Now here number of turns is what? In one coil only. So one, so N gone. So E is equal to minus times of d phi by dt. Now since they have asked the magnitude, so I'll take the mod value of this. Correct. So differentiate it. That's it. So phi is given as what? 3. This is not RT. So 3t square plus 4t plus 9. You divide d by dt. So I think so everybody knows the differentiation. That is equal to 6t plus 4. Now there's asked induced EMF at t equal to 2. Put the value t equal to 2. So what you'll get? 12 plus 4, that is equal to 16 volt. As simple as that. Clear everyone? Okay. So the EMF induced in a coil is equal to minus N d phi by dt. The number of turns was 1, only one coil we were asking, so 1. So N gone. Now they've asked for the magnitude. So magnitude, we just take the positive value, not about the direction. So negative is gone. So d by dt of 3t square plus 4t plus 9, if you differentiate it with respect to time, 3t square differentiation is what? 3 is outside, you take it. Differentiation of t square is what? 2t. So 60. And for 4, 4 is constant. Differentiation of dt by dt is what? 4. So done. Put the value. You got the answer. That's very simple. Now again in 2018, one more question came. Here what they've given, the magnetic flux linked with a closed circular circuit, okay, of resistance 10 ohm varies with time as phi is equal to this and the induced EMF they've asked. So again, E is equal to what? Minus d phi by dt. So differentiate it. So minus of d by dt of 5t square minus 4t plus 1. Correct. So what you will get here? Minus 10t plus 4. Correct. They're asking the EMF at zero point 0.2 seconds. Put t equal to zero point 0.2. So minus 10 into zero point 0.2 plus 4. So minus 2 plus 4, that is equal to what? 2 volt. That's it. So very simple question C. Correct. Now, next question is, a coil of 1000 turns has self-inductance of 120 millihenry. The self-inductance of the coil of 250 turns. See, first you need to remember the formula. Self-inductance formula. Every question, even the numerical, are directly formula based, nothing J and all that. Okay. L is equal to mu naught n square A by I. Now everybody, what is my n? N is our, sir, number of turns. What is A? Area of the cross section of the wire. So here that is constant because same wire we are using. So remove it, not needed. What is current? Same current we are using. So remove it, not needed. So L is, and mu naught is all, everybody knows constant. So L is directly proportional to what? N square. Correct. So the moment we know L is directly proportional to L square, N square, we can put the value initial N is equal to what? 1000 and L is equal to what? 120 millihenry. Final, we have N dash is equal to 250 and we don't know about L dash. So what I can write, L dash by L is equal to N dash by N, sorry, N square L square. So that is equal to, I'll put the values, that is equal to 250. N dash is what? My new one is what? 250. So 250 whole square by this one is what? 1000 whole square. And this one already I'm just taking it here, less space. L dash by old one is what? 120 millihenry. Correct. So let's solve it here. So L dash is equal to 120 into, I can take it in one form, 250 by 1000 whole square. So this is basically what? 1 by 4. So if I square it, I'll get 1 by 16. So if I solve, I think so I'll get 15 by 2, so 7.5. Okay, so this will be the answer. So very simple question. What is difficulty here? So you need to analyze a bit and you need to solve it. That's it. Next, a bicycle generator creates 1.5 volt at 15 km per hour. So again, formula. Induced EMF is equal to what, sir? Sir, BLV, sir. Sin theta is also there, but it is mutually perpendicular here. B, L, and V are mutually perpendicular. Correct. So EMF is, if B and L is not changing, EMF is directly proportional to what? Velocity. So E1 by E2 will be equal to what? V1 by V2. Correct. Because E1 will be proportional to V1 and E2 will be proportional to V2. Not different what you say. Take the ratio. They've already given the value. So E1 is 1.5 by E2 is equal to, first is what? 15 kilometer. Convert into meter per second. 5 by 18. 10 into 5 by 18. This gone, this gone. This is 1.5 only. So 1.5, 1.5 gone. E2 is equal to what? 1 volt. That's it. So what is the difficulty in this? So these are the questions that have been asked in the chapters of magnetism and matter and EMI. Very simple questions, very easy to understand. Go through the chapter, make a very short note on what are the formulas, just basic formulas. Self-inductance, mutual inductance, okay, and what is EMF induced and all that, because go through. You'll be able to solve all the questions. Okay. So best of luck, work hard, rest all. What do you say? Do subscribe for the channel if you haven't subscribed. Do share it with your friends so that whatever we are working hard, at least it reaches to each and every student. And if you see, it's not a very big thing, okay? Whatever the things which are coming up in the COMEDK, it will take, what do you say, around 10 hours to revise everything of COMEDK, okay? So if you want, if you go through, you'll be able to solve each and everything, okay? And it will be done in very less time. So do inform your friends, even if you haven't started now also, start, revise, watch all the videos. We have given a lot of them. So do watch it. We'll try to bring the maths PYQ by night or by tomorrow. We're working hard on that. Something or the other keeps coming up. So we'll try our best to put up every content, okay? And that's it. You work hard, share it, like it, comment it if you find it anything difficult, anything wrong, anything not proper. We take your comments very seriously. We work hard on that. And that's it from my side. Okay. Work hard, students. Best of luck.